Hey guys, now let us learn about the dynamometer. So, what is a dynamometer? A dynamometer is a brake which incorporates suitable arrangement to measure forces or a couple acting on the rotating body or the motion body at a rest. So now let us write the definition. A dynamometer is a brake which has a suitable arrangement in order to find the forces or couple acting on the rotating body. So now further, dynamometer is classified as absorbing dynamometer and transmitting dynamometer. Absorbing dynamometer and transmitting dynamometer. So now what is absorbing dynamometer and transmitting dynamometer? Here, as the name suggests, absorbing dynamometer is a dynamometer which is used to absorb the energy while working. Now let us write about it. It is a principle of absorption of available power in doing work, usually against the friction, to stop or slow the motion. Now the next is a transmitting dynamometer. As the name suggests, this dynamometer transmit all the power it receives while working in a particular system. So this absorbing dynamometer is basically used for force analysis, and the transmitting dynamometer is basically used for power analysis. Now further, absorbing dynamometer is classified as pony, prony, brake, dynamometer and rope brake dynamometer. Pony brake dynamometer and rope brake dynamometer. Now the pony brake dynamometer. It is a simple type of absorbing dynamometer. Simple type of absorbing dynamometer in which two wooden blocks each each having less circumferential area are pressed against the motor in order to limit its speed and forces. Now let us write the definition for rope brake dynamometer. It is a simple absorbing dynamometer. It consists of two or more ropes wrapped around flywheel of an engine whose force or power is to be measured. Now drawing the diagram for each. It basically consists of a drum which has wooden blocks spaced at equal distance and a measuring mechanism or scale. This is connected and rolled over with one rotation and then supplied with a weight. Sir, blocks. This is drum where the input power is gotten to the drum from the engine. So this is the scale, this is weight, drum, block, input from engine, input from engine. Now let us draw the diagram for the Brownie brake dynamometer. It basically consists of a drum which are holded upon and by the wooden blocks with the help of a mechanical spring which are mounted to keep both the blocks in contact with the application of forces. Here is the spring. And this whole mechanism is laid on the bar which is applied with the dead weight or known weight with the stops and here also the dead weight is provided or the balancing weight. Here now writing the names, the springs, balancing weight, this is pulley, and these are the wooden block, springs, and the distance from the center to that of the distance from the weight is L. From the center to that of the weight is L. Now writing the corresponding power transmitted from each of the mechanism. Now since the force is acting here, F, R, radius of drum, R. Now from the equilibrium condition, we have weight into L equals to F into R. Weight into L equals to F into distance R, where R equals to effective radius of pulley and W equals to weight and L equals to distance from center to weight and F equals to frictional force F. Now the frictional torque can be given as W into L, that is Fr, and power transmitted can be given as 2 pi NTF upon 60. Similarly, for the rope brake dynamometer, Here let it be radius r of the drum and radius r of the belt, along the belt. Here let it be s, w, weight w, scale s, weight w. Now torque transmitted would be W minus S into effective radius R, where effective radius R equals to radius of drum plus radius of rope, this rope, the whole. You can double it to understand rope. Now the power transmitted or brake power can be written as pi NPF upon 60. So this is the power transmitted. This is the torque, frictional torque for the Tony brake dynamometer and rope brake dynamometer. Now the transmitting dynamometer can be further classified as belt friction dynamometer and epicyclic train dynamometer. So this transmitting dynamometer can be further classified as belt transmission dynamometer and epicyclic train dynamometer. Now let us draw the diagram for the belt transmission dynamometer. Basically consists of two pulleys, somewhat larger pulley and a very large pulley. So the belts are like this. Belts are connected like this. These are fixed but can be rotated. Here the distance is r, rotating with angular velocity omega, and here we have another dead weight or balancing weight which is connected to both the upper pulleys, and finally to the weight. These are the stops in order to escape this area or limit. So now the distance between these two pulleys is A and A. Here tension is T1, T1, T2, T2. The overall tension acting downwards is 2T1, 2T2, Now from this diagram and applying the equilibrium conditions we get, and here the distance L is from here to here distance L, that is W into from conditions of equilibrium we get W into L equals to 2 times T1 minus T2 into A, 2 times taking 2 common, T1 minus T2 into the distance between them, center is A, that is T1 minus T2 equals to W into L upon 2A. Now torque transmitted would be TF T1 minus T2 into R, and finally power transmitted equals to 2 pi n frictional torque upon 60. So these were the various steps. And now for the epicyclic train dynamometer. It basically consists of a larger pulley and a bevel gear pulley with a dead weight with the application of weight, a bevel pulley and also another pulley with the force acting F upward with a balancing force in the rotation of the larger pulley clockwise. Here force acting 2F and here limiter in order to exceed this limit, and addition from weight to center is L, and from this center to this center is A. Now from figure, here the bevel gear is an input power transmitter to the outer drum. Now writing the equilibrium condition, that is W into L equals to weight W into L equals to force F into, it is 2F into distance between them A, that is F equals to W into L upon 2A. Here it was first, now second, that is frictional torque equals to Fr, and power transmitted equals to 2 pi n Tf upon 60. Okay guys, thank you for watching.